Hello all, I'm back with another international GCSE paper, and specifically this is paper 2P, okay? And from what I saw, there is also a paper 2PR, okay? I don't know what that means. I mean, to me, the paper seem to be alike, but let me know in the comments. Let me know what these codes are all about. I mean, if you know. And the only comment I want to make is that it wasn't part of the original plan to go over GCSE papers. I actually intended this channel to start with A-level papers and then leap into university level physics and such. But my analytics show that lots of the younger crowd watches these videos, okay? And I receive really nice comments, except for one comment that was kind of hurtful, but okay. I mean, there will be outliers, or maybe, okay, there will be cases in which people will find the way you teach difficult to follow. Okay, I mean, it's understandable. So anyway, let's dive in. This is from June 2025, so last year. I hope it's useful. So let's start. Oh, before we start, some of the things I always say about exam techniques is that this paper is timed at 1 hour and 15 minutes, so 75 minutes, right? And it awards 70 marks, I think. So you should devote about a minute per mark in the problem. So if a question awards 10 marks, it should take you 10 minutes, okay? I mean, that's a good way to time yourself so you don't run out of time and you score as much points as possible. And the other general thing I always say is that if you don't know how to work on a problem immediately, just skip it. Go solve problems that you know how to solve and then come back to solve the problem that you didn't know how to solve in the beginning, okay? Um, this will save you time. By solving other problems, you will gain momentum, confidence, you know. Whereas if you try to figure out a problem that you don't know how to solve, you're gonna waste time, get frustrated, etc. Okay. And finally, please use the formulas that they give you sometimes just by skimming through what they give you. So they give you formulas in the front of the paper and in the back of the paper. Okay. So sometimes just reading them will give you the inspiration needed, or something might click in your brain and figure out the solution to a problem. In fact, this happened to me several times when I was an undergrad student, when I was a graduate student, etc. I mean, sometimes you just see the formula and then it clicks. I mean, you can figure out what you need to do. Anyway, so let's start with the first question. You see there is a dice there. So a student plays a game using a single dice. The student decides to determine the density of the dice by measuring its mass and volume. Question A, describe how the student could accurately measure the mass of the dice. Okay, use put the dice on scales or a balance. So put the dice on a balance. Okay, so that's good enough. And another trick with these exams I've noticed, especially with the A-level exams, but also it's true for the GCSE level exams. Okay, so this awards 2 marks. Okay, so 2 marks means in case of questions like this where you have to write the answer, okay, it's not a calculation. So you see that putting the dice on the balance is 1 sentence. So we need 2, okay? So that's the rule of thumb with the mark scheme that I noticed. And after solving several of these exams myself for these videos. So the second point we can make here is that this is an experiment, right? So you have to zero the balance. So zero the balance before the measurement. And zero means maybe the balance is already displaying that the weight is half a kilo without even putting anything on the balance. Okay, so you have to zero that. Okay, so zero the balance before the measurement. Okay, and make sure the surface is flat. Okay, so we have 2 sentences. Let's move on. B. The dice is not a regular shape. The student decides to measure the volume of the dice using a displacement method. The student places the dice into a measuring cylinder containing water. The diagram shows the water in the measuring cylinder before and after the dice is fully submerged. Question I, the measuring cylinder gives volume in units of cubic centimeters. Using the diagram, determine the volume of the dice. So you see that we have the cylinder has 30 cubic centimeters and it goes up to okay, so that's 32, 34, 36, that's 38. It's in between 38 and 36. So let's call it 37 cubic centimeters. Okay, so 37 minus 30 cubic centimeters yields the volume as 7 cubic meters. Okay, so that's the answer. Part 2, the dice has a mass of 9.2 grams. Calculate the density of the dice using the formula density is mass per volume and give a suitable unit. So I'm going to call it rho, okay, which is known as the density, right? So 9.2 over 7 grams per cubic centimeters. So this is 1.31 grams per cubic centimeters. And let's switch back to black. I don't know why I'm using red. So this was question 1. Nice and simple, I would say. Okay, I mean, except for this first question in which you have to remember to include the second point about zeroing the balance. I think it's a straightforward problem. So we're ready to move on to question number 2. So this question is about sound waves. Which range of frequencies of sound waves can be heard by humans? I didn't expect to see a question like this in a physics paper because this is more of a knowledge kind of question. I mean, it's not something you can calculate on or reason about logically unless you know it. I mean, you can reason logically, but anyway, the answer is C, 20 to 20,000 hertz. I guess 2 hertz to 20,000 hertz is what dogs can hear, but I'm not sure. Let me know in the comments. So I guess this is something that they teach you in the class. Also, let me know that they actually teach you that, because otherwise, I don't know. I mean, to me, when I was reading the problem, I had to Google this to find the answer. So yeah, C is the correct answer, but A looked good enough to me as well. So anyway, so let's move on. B. The table gives some measurements about sound waves. Complete the table by placing a tick next to each correct statement. Sound waves are longitudinal. They are, okay, because they are compressions of air, right? And rarefactions of air. Sound waves can travel through a vacuum. This is one of the things, one of my very first scientific questions when I was a kid, like, I don't know, maybe 7 years old, 8 years old. So I was wondering, how do they communicate in space when I saw astronauts in orbit? I think it was the International Space Station back then. And then at some point I figured that all these space suits and the International Space Station, space station, excuse me, contains air, but you cannot shout outside the Earth because there is no air to transfer the sound. So that's wrong. Sound waves are part of the electromagnetic spectrum. That's crazy, no? And then sound waves can be reflected and refracted. That's true, just like all other waves. Okay, C. An oscilloscope can be used to display a sound wave. Give the name of the variable that is measured on the x-axis of the oscilloscope screen. That's time, okay? So time, t in seconds. Okay, let's move on. Question 2. The diagram shows the trace of an oscilloscope screen when a sound wave is detected. On the screen, draw the trace of a quieter sound wave with a lower frequency. Okay, so the period of any wave, okay, in this case for the wave we see here, the period is from peak to peak, so that's one period. Okay, is that correct? Yes. Okay, so the period is 1 over the frequency, right? So if the frequency is lowered, the period increases, okay? We don't need this. So a lower frequency. So actually, let me write it down. Lower frequency means longer period. Okay, and then lower quieter sound. Sorry, quieter sound means lower amplitude. Okay, so any wave will do, but we need to draw something. I'm gonna use green that has, okay, a lower, okay, something like this, a lower amplitude and a longer period. Okay, so the green dotted dashed actually line is a candidate. I mean, but you can draw other waves as well. I mean, this one will work as well. So something like this. Okay, it's quieter and has a longer period. Okay, so the purple one works as well. Okay, so this was question 2. Let's move on to the next question. Okay, question 3. The photograph shows a camper van with a solar panel on its roof. The solar panel is made from lots of solar cells connected together. I don't know if this is a joke about how me personally and many other people will live in the future. I mean, with the house prices we have now in Europe, especially. I mean, I live in Cyprus, but it's crazy expensive. And anywhere else in Europe is actually even more crazy expensive than Cyprus, I think. And in America as well, and with the unemployment that I am unemployed currently, and with the unemployment around the world, I don't know. In the end, we will all live in camper vans like this one with solar panels. Isn't that great? That was the dream, was it? Wasn't it? No, it wasn't. But anyway, so I can see some benefits though. I mean, with this kind of settlement, kind of with this kind of lifestyle, you can just travel around almost for free. I mean, you just park your van somewhere and you just stay. Of course, if you're on an island like Cyprus, there are not a lot of places to go. But if you're in the mainland Europe, you can go anywhere. So anyway, so let's move on. Okay. The solar panel is made from lots of solar cells connected together. I think I already said that. The solar panel is connected to a battery. The solar panel receives energy from the sun to charge the battery. Question A. Describe how energy is transferred from the sun's energy store to the battery's energy store. Okay, that's kind of crazy to start thinking about the sun's energy store. Okay, so let's do it. So it awards 3 marks, so you have to provide about 3 sentences. Okay, remember that kind of loose rule of thumb about problems like this. So the nuclear, because the sun produces energy using nuclear reactions, right? So the nuclear energy store of the sun decreases as energy is released. Okay. Energy travels from the sun to the solar panel, okay, by radiation. And the electromagnetic radiation can travel through vacuum, okay? So that's how it reaches us here on Earth from the sun. I will use a clean page to finish this problem. So this is still problem A. The solar panel absorbs this radiation, okay, and converts it to electrical energy. How do we know this? Because I don't know if they teach you this in class, but solar panels are made of semiconducting materials. These materials have the property of absorbing that as part of that radiation. Electrons are excited to what is called the conduction band of these materials, and this creates a current that creates electrical energy, pretty much. Okay, current is moving charge, right? So this electrical energy, okay, is then transferred to the battery, okay, increasing its chemical energy store. Okay, so you see the whole process. So the sun's energy is decreased a little bit, then the solar panel absorbs that energy from the sun, it converts it into electrical energy, which increases the chemical energy of the battery. Okay, so this is the whole process. Let's go back to read the second question. The petrol engine can also be used to charge the battery of the camper van. Give an advantage of using the solar panel instead of the petrol engine to charge the battery. Do not refer to cost in your answer. I mean, that was the first thing that occurred to me. Come on. So, okay, so let's write the other answers. So the first thing we can write is that solar power is renewable. I mean, it's not really renewable. After 5 billion years, it's going to run out anyway. But okay, 5 billion years is a long time, I guess. So solar power is renewable, so it will not run out. I mean, we say it's not gonna run out, but now I gave you the spoiler. It's gonna run out eventually as well, but in 5 billion years. Okay, and let me turn the page and write a few more things just in case. So another advantage is that solar panels do not produce carbon dioxide, CO2. Okay, and solar panels work without petrol. Okay, this is good enough. Let's move on. Part C, the surface of the solar panel is black. Explain why black is a suitable color for the solar panel. So it's a good absorber of radiation, pretty much. So black is a good absorber of radiation. Okay, this means that more radiation is absorbed and wait, let me think, what am I trying to say? More radiation is absorbed, so more energy is transferred to the cell. Okay, part D. The solar panel can charge the battery in the camper van with a maximum current of 15 amps. Again, the camper van is my future home. Okay. Calculate the minimum time to transfer 360,000 coulombs of charge through the battery. Use the formula charge transferred is current times time. So time then is, this is what we want to calculate, right? Yes, so time is charge over current. Okay, simple division, 360,000 over 15. So we have coulombs for the charge, and for the current, 1 amp is 1 coulomb per second. So if we divide this, we get 24,000 seconds. Okay, the answer is in seconds, so we are good to go. Okay. Okay, question 4. The photograph shows a mechanism that can be used to open a gate. Okay. The diagram shows the gate mechanism when the handle is being pulled to the right. Okay. The bolt is connected to the handle. When the handle is pulled to the right, the bolt also moves to the right and the gate can be opened. Okay, the spring is compressed when the bolt moves to the right. When the handle is released, the spring pushes the bolt back to its original position. Okay, good. Question A, when the handle is pulled to the right, the spring applies a force on the handle to the left. The vertical distance between the spring and the pivot point of the handle is 22 centimeters. The force from the spring is 5.2 newtons. Show that the force from the spring produces a moment of about 1 newtons per times meter. So the moment in this case is going to be the force times the distance. So 5.2 times 0.22 yields 1.14 newtons times meters, which is approximately 1 newton times meter. Part 2, state what is meant by the term principle of moments. So for a body in equilibrium, okay, the sum of the clockwise moments about a point equal the sum of the, okay, I'm gonna need a clean page, of the anti-clockwise moments about the same point. Oops. Okay. Part 3. Force F acts on the handle to keep the handle stationary so that the gate can be opened. Force F acts on a vertical distance of 70 centimeters from the pivot point of the handle. Calculate the magnitude of the force F. Okay, so we're talking about this force, okay, and the pivot is down here. So this force F times 0.7, the distance, should equal the moment we calculated earlier, right? Which is the moment by the spring, okay? Actually, let me use a different color. Okay, so the force pretty much is the clockwise moment, and the spring is the anti-clockwise moment. Because, yeah. Okay, let me think. Yes, because he wants to bring it back. Yes, okay. All right, so this should be equal to 1.14 newtons times meter. So the force is 1.63 newtons. Okay, moving on. Give two changes to this gate mechanism that would make it easier to open the gate. So use a longer hand. So use a longer handle, or use a weaker spring. And I mean a spring with a lower k, the spring constant. Okay, so it's a softer spring, if you will. Okay, this was question 4 done. Let's move on to question number 5. A student uses the apparatus to investigate static electricity. The positive charge ball is suspended vertically on a long length of string. Okay. The ball is made of a material that is a good electrical conductor. Name a material that is a good electrical conductor. I'm going to name copper. Okay. And in case you don't know, a little trivia for you. The chemical symbol is Cu, right? Which stands for cuprum. Okay. Which is the Latin name. So Latin for the metal of Cyprus, my home country. Okay. It used to be full of copper. I mean, there is still a lot of copper, I think, under the mountains, but they don't want to take it out because it's toxic. Not the copper, I mean the process, I think, of taking it out is toxic. So it's going to destroy the island pretty much. So, but then it was so abundant in Cyprus that the island was named after it. So anyway, part B. Oh, and other ones are silver, iron, any metal. So explain in terms of the movement of charged particles, how the ball has become positively charged. Okay, so we can say that the electrons were carried away from the ball. Okay, this left the ball with an excess of positive charge. So most things in nature are electrically neutral. Once you remove electrons from objects, then you make them positively charged, okay, because you're leaving behind the ions. Okay, let's move on to part C. The student places a centimeter scale behind the length of string. The string lines up with the 5 centimeter mark on the scale when the ball is in its resting position as shown in diagram 2. The student brings a negatively charged polythene rod near the right side of the ball. The ball moves as shown in diagram 3. Okay. Question I. Explain how the movement of the ball shows that the charge on the polythene rod is negative. So it basically moved, I mean the ball moved towards the rod. So if the ball is positive, then the polythene rod is negative because they attract each other. Okay, so the objects attract each other. I mean the force is to the right for the ball and to the left for the rod. So the objects attract each other, which means the ball is positive and the rod is negative. Okay, part 2. In diagram 3, the string lines up with the 7.2 centimeter mark on the scale. The student moves the polythene rod slightly further away from the ball. Predict the possible reading on the scale. So the force decreases with distance, right? So if it goes further away, so the ball will be between 5 and 7.2 centimeters. So let's say 6 centimeters, okay? And again, the reason is that if you bring the rod over here, then the distance between them increases, the force therefore decreases because the force is proportional to 1 over the distance squared. And we know that in equilibrium, it's going to be at the 5 centimeter mark. But because there will be a force, the maximum possible force is 7.2 when they are this close. So if it goes away, it's going to be between 5 and 7. I put 6. But I don't know, 6.2 works as well. Okay. All right, let's move on. Okay, question D. The student extends the investigation by measuring the reading on the scale for rods made from different materials. As a control variable, the student charges each rod by rubbing it with a cloth the same number of times. Give 2 other control variables for the student's investigation. Okay, so we can put the distance between distance between the ball and the rod. Okay, so you have to keep the distance the same, right? So that you can examine the effect of changing materials, right? And then the charge, so the initial charge on the ball must be the same. Okay, part E, the bar chart shows the results of the student's investigation. Justify the use of a bar chart to present the student's results. So the material is a categorical variable pretty much, right? And a categorical variable is anything that takes a range of values. So iron, silver, copper, ebonite, glass, nylon. Okay, so those are categorical variables. Good, very good, terrible. Okay, so these are also categorical variables and so on. Okay, so a bar chart is perfect for that. Okay. 2. Deduce what can be concluded about the charge on each of the rods used in the investigation. Use information from the bar chart to help you answer. Okay, so I will start with wood. So wood is at 5 centimeters. So remember that 5 centimeters is the equilibrium position, okay? Which means that there was no force on this object, okay? Which means that the wood is not charged, pretty much, okay? So let's go back and read it. So wood, no charge, okay? Since there is no motion. Okay, now let us continue with, I'm gonna erase this now. Let's do polythene and ebonite. Okay, both of these have displaced to more than 5 centimeters, so something like this, okay? Which means that they are negatively charged, just like the rod, okay? Because they attract the ball pretty much to the right. So let's write this down. Polythene and ebonite, negatively charged, okay? With ebonite, more negatively charged than polythene. And how do we know that? Because ebonite has the largest displacement. Okay, so, and now we're left with the other 2 materials. Let's use green. So glass and nylon actually move to the left. Okay, so they move there. Okay, which means that, they move the ball to the left, which means that they're positively charged, okay, because they repel the ball. Okay, so the ball moves to the left and these materials move to the right. Okay, so let's write this down. Glass and nylon, positively charged, and glass is more positively charged than nylon. Okay, this was question 5, which is not done. Let's move on to question number 6. Question 6, this question is about gamma radiation. Which of these statements is correct for gamma radiation? Option A, gamma radiation has a weaker penetrating ability than alpha. That's the other way around, actually, so that's wrong. B, gamma radiation is emitted by electrons in atoms. It's wrong, kind of, I mean, no, it's wrong, but what I'm trying to say is that X-rays and UV light and infrared light is emitted by electrons. Gamma rays is actually emitted by protons and neutrons inside the nucleus, okay? In case you don't know. Okay, option C. Gamma radiation is positively charged. It's electromagnetic, so it doesn't have charge. So D, gamma radiation is less ionizing than alpha radiation. That's actually correct. So let's choose it. B, a student uses a simulation to investigate gamma radiation. This is the student's method. Place a Geiger-Müller tube a distance of 6 centimeters from a source of gamma radiation. Measure the count for a time of 10 seconds. Move the GM tube farther away from the source and measure the count again. The student measures the count 3 times for each distance. Give a reason why the student takes repeat readings. So this is to calculate an average count, okay, which reduces the effect of random error or anomalous results. Okay. Part 2, the graph shows the students' results. Okay, we see the mean count, and as we increase the distance, the counts reduce in kind of like a parabolic fashion. So the student claims that the data obey the formula count times distance squared is equal to a constant. Evaluate the student's claim. Okay, first of all, let's come to this graph. Each one of you is going to have different results depending on how you read these data points, okay? So, but okay, let's mark this data point. So the counts for this one, I think, are 13,600 and the distance is 6, okay? So these are the counts, and this is the distance, okay? And let's do the same for the other points. So for this one, I think it's 3,406. Then for this data point, we have 1,550, and then the distance is 18. Okay, then for this data point, we have 924. And then for the last data point, we have 530. Okay, so these are the pairs of counts and distance, and now we have to take the counts and multiply by the distance squared for all these measurements. So I'm going to do it on this page. So for the first data point, we have 13,600 times 6 squared, and we find 489,600. Okay, and I'm going to do the same for the others. I'm going to speed up the video probably here. Okay. Okay, so these are all the values. You see that they are kind of close, like from between 450,000 and 520,000, something like that. So we're going to say that values are approximately the same. So surprisingly, I'm kidding. Okay, so student is correct. Okay, so this was question 6. We can now move on to question number 7. Question 7, this question is about transformers, not the robots, this kind of transformer, okay? The not so cool transformer. So, question A, the diagram shows a step-down transformer, okay? The table gives, okay, we see the primary coil with more turns and less turns for the secondary coil as normal. Okay. The table gives some data for the step-down transformer, input voltage, input current, and so on. Okay. Question I, state the formula linking input, primary voltage, output, secondary voltage, and the turns ratio for a transformer. So the primary voltage over the secondary voltage is equal to the number of turns in the primary coil over the number of turns in the secondary coil, and that's it. 2. Use data from the table to calculate the output secondary voltage of the transformer. So V secondary is N secondary over N prime times V prime. And now you have to trust me because I read the table. 300 over 1000 times 230 yields 69 volts. 3. the transformer, excuse me, is not 100% efficient. The efficiency of a transformer can be calculated using the formula useful output over total input times 100%. Calculate the efficiency. So the efficiency is the useful power is pretty much the current in the secondary coil times the voltage in the secondary coil. Okay, so this is what they call the power in the secondary coil, or the useful power. And similarly, we have to use the in the primary coil times the voltage in the primary times 100%. This is equal to 4 times 69 over 1.3 times 230 times 100% yields 92.3%, which is great. I mean, it doesn't sound that bad. All right. And finally, part B. Explain how transformers are used in the efficient, large-scale transmission of electrical energy. You may draw a diagram to help your answer. 5 marks, okay? Means you have to provide about 5 talking points, 5 sentences, something like that. So let's save some space and start from up there. So a step-up transformer, okay, is used before the electricity enters transmission lines. Okay, this increases the voltage, reduces the current. Okay, a lower current in the cables means less energy is wasted in heat. Okay, so means less energy is wasted in heat. Okay, in the cables. Okay, and you can write that heating effects. This is in parentheses. It's not needed, but it's good to know. Heating effects depend on current squared. Okay, so after transmission, okay, a step-down transformer, okay, reduces the voltage back to safe levels for household use. Okay, this overall process means much less energy is wasted compared transmitting low voltage, high current. Okay, this was long as an answer. This is long, excuse me, but I think it's complete, and you should get full marks with this question. Sorry, with this answer. Okay, next one is question number 8, the last one in this test. Okay, question 8. This question is about cosmology. Give 2 pieces of evidence that support the Big Bang theory. So the first one is the cosmic microwave background radiation. Do we have to write anything more? I mean, you can write, okay, let's use a clean page. Okay. So this is a low energy microwave radiation detected at all directions. Okay, which is remnant heat released in the Big Bang. Okay, and the second one is the redshift of galaxies. Okay, and this shows that the universe is expanding. So the universe is expanding, which means that it originated from a single point. Okay. B, the galaxy NGC 300. I've never heard of it before. If you did, let me know in the comments. And by the way, about the comments, guys, I noticed that about 90% of the people now who watch these videos are not subscribed, which is kind of sad. So it would be nice if you can subscribe. Okay. So NGC 300 is moving away from the Earth at a speed of 1.44 times 10 to the 5 meters per second. Hydrogen atoms in NGC 300 emit light with a reference wavelength of 4.3 3405 times 10 to the negative 7 meters. Calculate the wavelength of this light when it is detected at Earth. Give your answers to 5 significant figures. Okay, so let's calculate the z factor. So that's the velocity of the galaxy over the speed of light. So 1.44 times 10 to the 5 over 3 times 10 to the 8. Okay, so that's 4.8 times 10 to the negative 4. So this z is equal to delta lambda over lambda reference, and delta lambda is lambda minus lambda reference, and this should be equal to z times lambda reference. So lambda is going to be lambda reference plus z times lambda reference, and if you do this calculation you will find 4.3426 times 10 to the negative 7 meters, and these are the 6 figs that they ask, so you're good. And also notice that this is longer than the reference wavelength, okay, which is the essence of redshift. It means that it moves towards the red. Red is 700 nanometers, okay, so the radiation moves towards that limit. Okay, let's see another galaxy. Centaurus A is much farther away from the Earth than NGC 300. Explain how the wavelength of light detected from hydrogen atoms in Centaurus A is different from the wavelength of light detected from hydrogen atoms in NGC 300. So Centaurus A, the mythological creature, but I also haven't heard of this galaxy either. So this galaxy is much farther away, okay, farther away, hence it's moving faster than NGC 300, okay, which is the Hubble's law, right? So Mr. Hubble figured out that the farthest away a galaxy is, the faster it's moving away from us. Okay, so since V factor is equal to V over C, okay, if V is larger, then Z is also larger, okay, hence lambda is going to be lambda reference plus Z lambda reference. Therefore, lambda is going to be more red shifted. Okay, so this was question 8, and this concludes the paper. Okay, so this paper 2. Forgive me for not having too many GCSE papers. Again, the initial idea was to do A-level papers and A-level material and then move to university level physics, but due to demand, I'm trying to upload as many papers as I can. I have a very loose plan about presenting a research paper at some point, okay, but that's not for high school students. I mean, it is, you're welcome to watch if I ever make it. But anyway, I started having plans for this channel. Thank you guys for watching. Some of you leave really lovely and touching messages. Okay, I never expected for these videos to reach people in all corners of the earth, as they say. So I hope I can keep it up. The channel is not monetized yet, which makes it very hard to keep up because I mean I need to make a living somehow. Okay, but okay, if the channel keeps growing, at some point I might be able to make some living from it. It wasn't the original idea. I mean, I always wanted to have a YouTube channel, to be honest, since at least 10 years ago, but I never got around to make it. And I'm currently unemployed, so kind of it makes me have something to do. And I'm still interested in doing physics research, but I don't know how at this point, so we'll see. Thank you guys for watching. Let me know what you think about these videos in the comments, and thanks for those of you who already did that. and it seems like I'm doing an okay job. I can improve the handwriting. um I'm thinking about other ways I can improve, but okay, these are, physics papers, so you just solve problems. So in the future, I hope I will have more videos that will involve, I don't know, maybe going outside the room, maybe going out in the streets, doing interviews. I don't know. We'll see. I'm still thinking about ideas. I mean, let me know about ideas you would love to see me doing. So anyway, guys, thanks again, and see you in the next video. I hope I will upload more, but summer is here, so I don't know. We'll see. Bye, guys.